If the top carnivore in the food web is removed, it can mess up the whole balance of the ecosystem. The animals that the top carnivore used to eat will start to grow in number because nothing is hunting them anymore. As their number grows, they eat more food, like plants or small animals. This can cause those food sources to run out or get damaged. Other animals that rely on the same food might struggle to survive. Over time, this can lead to fewer types of animal and plants in the area. That's why top carnivores are important. They help keep everything in balance. Each organism in a food web belongs to a specific trophic level based on what it eats. Plants and algae are at the first level called producers because they make their own food using sunlight. Animals that only eat plants like rabbits, mouse, or grasshoppers are primary consumers. Animals that eat herbivores like birds and frogs are secondary consumers. Some animals like hawks, wolves, and foxes eat other carnivores and are called tertiary consumers. If an animal eats more than one level, for example, a bear that eats both fish and berries can be a part of more than one trophic level. This shows how organisms play different roles in food webs depending on what they eat. An inverted pyramid happens when there are fewer producers at the bottom and more consumers above them, which looks upside down from how it normally should be. This can be seen in ecosystems like the ocean, where small producers like phytoplankton reproduce very quickly, even if there are many of them at once. Even though they are small and few, they can still support many larger animals like fish. However, this is not a good way to show energy available in an ecosystem because energy always decreases as you move up the food chain. Only about 10% of the energy is passed to the next level, so there is always more energy at the bottom. A pyramid with more consumers than producers does not show this energy loss properly. A pyramid of energy cannot be upside down because energy is always lost as you go up each level on the food chain. When an animal eats another organism, it can only have about 10% of its energy from the food. The rest of the energy goes towards moving, growing, or losses heat. This means most of the energy is at the bottom with the producers, like plants. There is less energy available for herbivores and even less for carnivores at the top. If the pyramid was inverted, it would wrongly show that top predators have more energy than the levels below them, which isn't possible. That's why a pyramid should always be right side up. The difference between rapid and slow cycle comes down to how quickly nitrogen moves through the environment and where it's stored. Rapid cycle processes happen very quickly and involve living things. These include nitrogen fixation by bacteria, plants taking in nitrogen, animal eating those plants, and nitrogen returning to the soil by waste or decomposition. These steps can happen in days, weeks, or years. Slow cycle processes take a longer time. In these, nitrogen gets stored in deep ocean sediments or become parts of rocks and fossil fuels. This can take thousands or even millions of years for that nitrogen to come out into the cycle, usually through volcano activity or burning fossil fuels. So in nitrogen cycle, rapid processes involve the environment, soil, and living things, while slow processes involve deep storage and take a longer time. In the nitrogen cycle, human activities cause imbalances in several important ways. One major way is through the use of synthetic fertilizers in farming. These fertilizers add extra nitrogen into the soil, much more than natural levels. This excess nitrogen can run off into rivers or lakes, causing algae blooms that harm water life by reducing oxygen levels. Another source of interference is the burning of fossil fuels, which releases nitrogen oxides into the air. These gases can lead to acid rain and contribute to air pollution and climate change. Also, raising large numbers of livestock produces a lot of nitrogen-rich waste, which can overload local ecosystems if not managed properly. All of these actions speed up the nitrogen cycle and add more nitrogen than ecosystems can handle, leading to environmental problems. Humans can reduce their impact on nitrogen cycle by making smarter and more sustainable choices that still support farming, clean air, and good living conditions. One way is by using less synthetic fertilizers or switching to natural fertilizers like compost, which release nitrogen more slowly and are less likely to run off into water. Farmers can also plant cover crops and use crop rotation to naturally improve soil nitrogen levels. Improving waste management in farms and cities can help keep nitrogen from polluting the air and water. Reducing the burning of fossil fuels by using cleaner energy sources like wind and solar power can also cut down nitrogen pollution in the air. These changes help protect ecosystems without harming food production or people's way of life. By using technology and smarter practices, we can balance human needs with the health of our environment.